Good afternoon, my YouTube viewers. In this particular video, we're going to do a difference of mean test that's going to be a little bit different from the difference of mean test that we did in the last video, because this difference of mean test is we're going to be testing the means of the male and female Olympians. So basically what we're going to do is we're going to compare the heights of male and female Olympians. So your null hypothesis is the male mean equals the female mean. And the alternate hypothesis is the male mean does not equal the female mean. So what we're going to do is we're going to write a program in Python to carry out this difference in mean test. And we're going to import 3 libraries in order to execute the program. The first library that we're going to import is NumPy as NP. NumPy is a numeric library that performs numeric calculations. It creates NumPy arrays, and it also creates distributions. We're going to import scipy.stats as stats. So scipy is Python's scientific library, and stats is a statistical library within scipy. A statistical module within scipy. And then we're going to import matplotlib.pyplot as plt, which is a visualization library. So after we have imported our 3 libraries, then what we need to do is we need to define our parameters. So the male mean is 182 centimeters. The male standard deviation is 10 centimeters. And the male samples are 100. The female mean is 170 centimeters. The female standard deviation is 9 centimeters. And the female samples is 100. So already you can see that the male mean is 12 centimeters higher than the female mean. So you already can see that. And then your alpha is got a 0.05, which is your significance level. So first thing we're going to do is we're going to calculate our t-score. So the t-score equals male mean minus female mean divided by the square root of the male standard deviation squared divided by male samples plus the female standard deviation squared divided by female samples. And so your t-score is 8.9195. And then next thing we're going to do is we're going to calculate the degrees of freedom using the Weld-Satterthwaite equation. So your degree of freedom equals male standard deviation squared divided by male samples plus female standard deviation squared divided by female samples squared divided by male standard deviation to the 4th divided by male samples squared times male standard deviation minus 1 plus female standard deviation to the 4th divided by female samples divided by 2 times female samples minus 1. And so that is the formula, and it is a pretty long formula, but that's how they calculate the degrees of freedom. And then after we calculated our degrees of freedom, what we're going to do is we're going to calculate the p-value for a 2-value test. And p-value equals 2 times brackets 1 minus stats.t.cdf brackets absolute value of p-score df. So your t is your t distribution, and your CDF is your cumulative distribution function, and your DF is your degrees of freedom. And then so what we're going to do is we're going to output the results of your t-score and your p-value. And then we're going to analyze the alpha and the p-value. So your alpha is 0.05. So if your p-value is less than 0.05, you're going to reject the null hypothesis. There is a significant difference between the heights of the male and female Olympians. If the p-value is greater than the alpha of 0.05, you're going to fail to reject the null hypothesis because there is a significant difference between the male and female Olympians. So we're going to plot the t-distribution. X equals np dot line space brackets -4, 4, 1000 brackets. Y equals stats.t.pdf and brackets x, df. So t is the t-distribution and pdf is probability density function. So we're going to plot the t-distribution. plt.plot brackets x, y, label equals t-distribution, color equals blue. We're going to fill in the critical region. Critical value equals stats.t.ppf brackets 1 minus alpha divided by 2, df. And then the t is the t-distribution and ppf is the percentage point function and df is your degree of freedom. So plt.fill between brackets x, 0, y, where x is less than or equal to negative critical value or x is greater than or equal to critical value, color equals red, alpha equals 0.5, label equals critical region. So now we're going to put the t-score on the plot. plt.axSpeakLine brackets t-score, color equals green, line style equals dashed, line width equals 2, label equals t-score. And then we're going to add titles and labels, and that's going to be, the title is Two-Tailed T-Test Comparing Heights of Male and Female Olympians. And your X label is your t-score, your Y label is your probability density, and then you've got your legend. So we've got we're going to show our work, show the graph. So your t-score is 8.9195 and your p-value is 0. And since your p-value is less than the alpha of 0.05, that means you're going to reject the null hypothesis. There is a significant difference between the heights of male and female Olympians. So this is the graph that we have made. And so blue is your t-distribution, red is your critical region, and t-score is in the green. And so you can see that the t-score is way off the line. And so that is how you do a difference in means test and you compare male and female heights. So I'm going to go ahead and close this video, but the next video will be another difference in means test, and I hope you decide to watch it.